So let's expand on this whole concept of filtering using a kernel. And this time around, what I'd like to take the concept of cross-correlation to define the concept of convolution. Let's start off with again, a simple image. Here, actually, there is, of course, a interesting variant on this image. This is sometimes referred to as an impulse image because, in essence, what I have is zeros everywhere else and then a peak, the brightest value, and then down to zero. And again, there's only one simple impulse in this image right here. So zeros everywhere else and a bright peak in the middle is what we're looking at for this image. We want to do a cross correlation, in this case, a filter with a kernel like this. And we will take a kernel just to have values. We've been playing around with these parametric values of A, B, C, D, E, F, G, H, I to represent this kernel. What we're now interested in asking the question, what happens if we slide this kernel over this image here, this example image, and what would be the output? So this would be the output that we would actually like to generate. Of course, this is the output Gij. What we would like to do is now take the cross correlation of this with the kernel and start filling in the values here. Let's start off with the region here. Again, we just do a cross correlation of this with that. All of the values here are multiplied by a 0. So the answer here would be 0. Let's now move this 1 like that. And of course, the computation here, if you look at this region with this, f multiplies by 1. The answer here would be f. Move this by 1 again. Do the computation, e multiplies by 1. The rest of them are 0. The response output here would be e. Next one, d multiplies by 1. Response here should be d. Moving one more, we get to 0. And of course, now we should fill in the other two rows also. So this is basically what my response would look like if I took an impulse function with a cross-correlation kernel. Kernel like this, do a cross-correlation, and our answer response would be this. To reiterate, taking this kernel on an impulse image like this, doing a cross-correlation, this is the response we get. Let's look at this 3x3 region. If you notice, an interesting thing happened, and we constructed this, and you notice what was happening. D, E, and F got switched, and similarly, B, E, H, H, E, B have been switched. So in essence, what has happened is this, there's been a flip in this axis, right? And there has been a flip in this axis. Both axes, there has been a flip. So this is what my output region of this 3x3 looks like. And again, as I noted, they've been rotated. One axis, another axis, and of course I can flip it. And this is my kernel. So in essence, what happened by doing this process was the internal parts all got flipped around. So the bottom line of this exercise we went through was to showcase that if you have an impulse function like this, and you have a kernel that has different properties like this, these values here, we do cross correlation, the result is a reverse response. Let's look at that with a real example. Here what I've done is basically created an original impulse function, black values here, white peak in the middle. Let's actually create a simpler version of this too. Showcased here, black value, white here, and ramps going up this way and also coming up this way. So different gray values here, 0, 1, and different values here. And let's see what happens when we run this process. So the actual output is, again, if you notice, just like this, but flipped in both axes, both in X and Y, or horizontal and vertical. So now let's look at exactly what happened. This is referred to as a convolution method, and a convolution is basically a mathematical operation where we take two different functions. F was our input, H was our kernel, and it actually produced a third function that actually modifies the answer, and it actually gives the area of overlap between the two first functions. And it actually does that by basically showing an amount that one of the original functions is translated by. Lots of words basically showing what we actually looked at in mathematical version, or at least a practical version. Let's look at it with math.